morning all. In today's topic, let us discuss about Heisenberg's uncertainty principle. In 1927, Heisenberg proposed this principle. Okay. So, if we take classical mechanics, in classical mechanics, at any instant, moving particle at any instant has a fixed position, right, as well as a definite momentum. So, if we know its initial values, then we can determine these quantities. Okay. So, according to classical mechanics, if a particle at any instant will have a fixed position and definite momentum, if we know their initial values, then we can determine these two quantities. Okay. Now, according to wave mechanics, here particle is described in terms of wave packet, right? So, what is wave packet? So, it is nothing but the group of waves. In my last lecture, we talked about this wave packet. Okay, it is nothing but the group of waves. Within this wave packet, at any position, the particle can be located. Within this wave packet, at any position, the particle is located, right? If wave packet is small, then the position of particle will be fixed, right? But the particle will spread rapidly. As particles spread rapidly, velocity becomes indeterminate. So, it says that when wave packet is small, we can find the position of the particle, but we find indefiniteness in finding the velocity. That is, we cannot find the exact value of the velocity. Similarly, if wave packet is large, then we find indefiniteness in position. Okay, we find indefiniteness in a position of particle, and velocity is fixed. Means we can find velocity, but we cannot find the exact position of the particle when wave packet is large. So, from these two, that is, when wave packet is small, what is happening? We are finding the exact position of the particle, but indefiniteness in velocity. When wave packet is large, velocity is fixed, but we will find indefiniteness in the position. That is, if there is a certainty in position, there will be uncertainty in momentum. If there is certainty in position, we find uncertainty in momentum. Uncertainty in finding the momentum. And if there is a certainty in finding the momentum, then we will find uncertainty in position. So, from these discussions, we are understanding that either we can find the exact position of particle, okay, or we find the exact momentum of the particle, means position and momentum simultaneously cannot be measured. Simultaneously we cannot measure the position and momentum of particle up to desired degree of accuracy. This we call it as Heisenberg uncertainty principle. So according to Heisenberg uncertainty principle, it is impossible to specify or measure both the position and momentum of a particle simultaneously to any desired degree of accuracy. This we call it as Heisenberg uncertainty principle. So overall we can say that if we can locate the exact position of a particle, we find indefiniteness in momentum. If we calculate or measure exactly the momentum value, then we find indefiniteness in the position of particle. Okay. Now, if delta P is uncertainty in determining the momentum, right, and delta X uncertainty in determining position of particle, then we can say that delta P, delta X is never smaller than the order h by 4 pi. Then the product of uncertainties in determining the position and momentum of particle can never be smaller than order h by 4 pi. That is, delta Px delta X is greater than or equal to h by 4 pi. Or in terms of if delta is the uncertainty produced in energy, delta T uncertainty produced in time, then delta E into delta T is greater than or equal to h by 4 pi, right? Similarly, we can also write, if delta J uncertainty produced in angular momentum and delta theta uncertainty produced in angle, then this is also the product is greater than or equal to h by 4 pi. So this is about Heisenberg uncertainty principle. Thank you for watching.